I'm Ruth Carisu, and I am a NASA Solar System Ambassador. And I'm pleased to be joined by two other Solar System Ambassadors, Richard Stember and Dr. Mikkel Perry. NASA's Solar System Ambassador program is run by the Jet Propulsion Laboratory in Pasadena, and the program trains about 1,000 of us, all volunteers throughout the country, to inform the public about NASA missions, science, and technology. Richard Stember has a Bachelor of Science in Chemistry from the State University of New York. He owns and operates a company that develops software for scientists, and he's also an avid amateur astronomer. He'll be operating the telescopes we're using tonight. In 2014, he founded Science Heads to share his love of science and astronomy with the public and serves as its executive director. Science Heads is a nonprofit organization here in Orange County, California, whose mission is to promote and support STEM education and science literacy. Dr. Perry has her master's and her PhD in astronomy from the California Institute of Technology. Before retiring, she designed spectroscopy instrumentation for the Palomar Observatory. Now she's focused on demystifying science and math for children and adults using outreach events like tonight's party. I have a Bachelor of Science in Chemistry from Ursinus College in Pennsylvania, and I did my graduate work in industrial technology at Cal State Long Beach. I also hold an MBA from UCLA's Anderson School of Management. In my professional career, I was an analytical chemist, a nuclear quality engineer, and an entrepreneur. My claim to space fame is that my company, Solder Mask, supplied components for the International Space Station. So a few bits of housekeeping. Please keep your microphones on mute and keep your video cameras turned off. We do that to conserve bandwidth. And since we're bringing images to you from halfway around the world, we need to conserve bandwidth. We welcome your questions. We ask if you would type them into the chat box, and we'll try to answer as many as we can tonight. If we don't get to them, we will post the answers on our website at scienceheads.org. We're also recording the presentation tonight, so you will be able to view it later or share it with friends. To maximize your screen, look at the very top center. It said View Who's Talking. Click on that. And when you do, you can say, just click on Who's Talking, and then you can move the camera view. I would suggest moving it to either the left or the right side of your screen. So with the housekeeping out of the way, let's get this star party started. Science Heads has a mobile observatory that we take out to schools and community events. But since we can't do that right now, we decided we would bring the telescopes to you. So Richard, can you tell our guest about the telescopes that we'll be using tonight?
I'd be happy to, Ruth. We're actually scheduled to use two telescopes tonight, and I'm going to go ahead and advance to a slide here. Yep, there we go. One of them is located in the South American country of Chile, as illustrated on the map on the right-hand side there, and the other is located on the Canary Islands off the western coast of Africa. These are both excellent locations for telescopic viewing. So we're very fortunate to have access to these telescopes.
Why are they so good for viewing?
Well, for example, the telescope on the Canary Islands is on the slope of an extinct volcano. That volcano is about 12,000 feet in altitude, so these telescopes are very high up. They're approximately 6,000 feet in altitude, above much of the atmosphere. In fact, if you look at that picture on the upper left there, you can see the clouds down below the observatory that we're using. And of course, if you're high up in the atmosphere, there's less distortion, less weather to deal with. So it promises to give us some excellent viewing tonight.
So you're sitting in your office in Lake Forest, California, and these telescopes are halfway around the world. So how do you remotely control them?
Well, that's a really good question, too. So like a lot of professional astronomers, Amateur astronomers could also subscribe to remotely controlled telescopes. The telescopes that we're using tonight come from a website called slew.com, as indicated in the upper left of this slide I'm sharing with you. And anybody can sign up for a subscription and then schedule telescope time. They can point the telescopes at particular objects or coordinates in the sky when they are available.
So how does the telescope work?
Well, I've got a little graphic here to show you that. Here's a picture of one of the telescopes. It is a 14-inch wide telescope. It's pretty big, actually. It takes about 2 people to lift it. It's very heavy. It has a combination of lenses and mirrors. We call it a Schmidt-Cassegrain or SCT type of telescope. And as the light diagram shows here, the light enters from the top. You can see the Big Dipper there. The light from which is entering from the top. It goes to the bottom of the tube where it's reflected back up again off of a convex mirror. And there's a smaller mirror lodged in the lens, the corrective lens at the top of the telescope, which bounces the image back through a hole that's cut in the primary mirror. And once the light goes through that hole, it lands on an imager, which is much like an expensive camera. The one that we're using is pictured here. And also attached to that camera is a set of filters and a filter wheel. And in fact, the images that we're going to collect today are going to appear in black and white, but there'll be 4 images for each object. Those images will be in different colors or wavelengths, as we say. And later on, we'll be able to combine those images into one beautiful color image.
So how does this color image compare with images, say, from the Hubble telescope?
Well, there's really no comparison, I'm afraid to say. This is a pretty big telescope, a 14-inch telescope that we're using. Hubble is much larger. It's about 6 feet in diameter, but more importantly, it's in orbit around the Earth. It's way above our atmosphere, and our atmosphere interferes a lot with astronomy, with astronomic viewing here on the surface. With all the clouds, of course, it can prevent viewing. But turbulence in the air and moisture and various other effects can reduce the quality of the image that we get here on the Earth. But Hubble produces some incredible images. We'll take a look at some of those images as well tonight.
Yeah, we will. But before we go to the moon, how about if you give us a little bit of history about it? How many people have actually walked on the moon?
So, 12 people have walked on the moon, Ruth. Let's go to this graphic here. The first people to walk on the moon was Neil Armstrong and Buzz Aldrin, our first astronauts to walk on the moon in the Apollo 11 mission. They had the pleasure of doing so while Michael Collins remained in orbit around the Earth. 6 missions followed, 5 of which successfully landed. Their landing zones are indicated on this graphic here, and we'll be able to identify them when we look at the image from the telescope as well.
Well, I'm old enough to remember when Apollo 11 landed and I was glued to the black and white television set watching it. When was the last NASA's manned mission to the moon?
So I remember the first. I was old enough to be sitting in front of my television with my parents watching Neil Armstrong step off the ladder. I also remember the last, and that was Apollo 17. And it's hard to imagine. That was back in 1972. We haven't had boots on the ground on the moon since the early 70s. What I find really interesting about that is that it was the only mission that actually had a scientist on board. Harrison Schmitt was one of the 2 astronauts who walked around on the surface of the moon. These astronauts also had a buggy pictured here to drive around. And Harrison is a geologist, has a PhD in geology. And because we sent a scientist, we actually learned quite a bit on that mission about the geology of the moon.
Will we send people back to the moon?
You betcha, as they say. NASA's got some really exciting plans. In fact, we have a new rocket. Let's advance over to that, called the Space Launch System. This rocket is bigger and more powerful than the Saturn V, which carried the NASA astronauts to the moon. It's designed to last many missions and many years. It's in fact designed to even carry astronauts all the way to Mars. A new capsule has been designed as well. It's called the Orion capsule. We have flown it once already, unmanned, and there'll be another mission coming up in just a few months as well. The Orion capsule is larger than the Apollo capsule. Inside, it's about the size of a minivan. It can hold up to 6 astronauts. Lunar mission will have 4. And as part of that mission as well, we're going to be building a space station that'll be in orbit around the moon, and new landing craft, which are in the process of being designed as we speak. When is this all going to happen? The plan is to have boots on the ground again in 2024, and this mission is called the Artemis mission. Artemis, for those of you who remember their Greek mythology, Artemis is the twin sister of Apollo. And NASA has promised that there will be women astronauts landing as part of the Artemis mission. So it's pretty exciting. Look forward to, in just a few years, 4 years from now, we're going to have the first woman on the surface of the moon, and the next astronauts all working for days, if not weeks, on the surface.
And part of the Artemis program is to actually land astronauts on Mars. So maybe some of our young visitors tonight will be astronauts putting boots on the ground on Mars. So we've sent people to the moon before, not for many years, obviously, but why are we doing it again?
I get this question a lot, and it's a very good question. Both our political leaders and our scientists believe there's many good reasons to return to the moon. First off, NASA is going to be using it as a proving ground for new technologies for the mission to Mars, as you mentioned. So it's important to be able to have the experience to develop and test this new technology. From a scientific perspective, we learned a lot about the moon during the Apollo missions, but we've also learned a lot since. For example, since the Apollo missions, we learned that there's actually frozen water on the moon. And we learned about lava tubes and lava pits on the moon. We learned that the moon is shrinking. And the current theory about the formation of the moon is that it formed after a collision with the Earth, and that debris coalesced and formed into the moon. So the moon is actually made up of the interior of the Earth. So studying the moon tells us a lot about the composition of the Earth itself.
Can we access the telescope and see the moon?
Yeah, let's do that. So I'm going to switch over now to the telescope.
While you're transitioning to the telescope, Richard, I'd like to remind everyone to keep your microphones off. And if you have questions, please type them in the chat box and we will address them. So again, questions, please type them into the chat box, which you access by clicking on the little balloon on the upper right corner of your screen.
Thank you for the reminder, Mikhail.
So let's take a look. We've captured an image of the moon a little bit. I'm sorry, captured an image of the moon a little bit earlier. Let's bring that up here. And there it is. So what you're seeing now is an image that we captured of the moon a little bit earlier, not just a moment ago. And there's some really interesting features to see here. First off, we can actually see many of the landing sites, the sites where the Apollo missions landed. let's identify those. So here in this area, I'm going to draw a red circle around it. That's a much bigger area than was explored by the Apollo 11 astronauts, but they landed roughly in that area there. It was on the edge, and let me correct myself. I drew it in the wrong spot. Bear with me here. I want to be accurate. Yeah, Apollo 11 landed right over here. That is the area called the Mare Tranquillatus, which is Latin for Sea of Tranquility. In ancient times, people looking at the moon thought there were oceans and seas on the surface. They saw these dark areas, and they thought they must be oceans. So they gave them names. And this one was called the Sea of Tranquility. That's where Apollo 11 landed. Apollo 17, the last mission, landed up in Mare Serenitatis, the Sea of Serenity, and that's in this area right here. That's where Apollo 17 landed. There's some other interesting features here as well. Let me zoom in a bit. You can see a lot of detail on the surface of the moon, and we're traveling over it now, much like the Apollo astronauts did when they were moving laterally across the surface looking for their landing zone. We can see craters, we can see ridges, we can see ejecta, lines of essentially soil, or what we call regolith, that's been thrown out from asteroids hitting the lunar surface, creating craters. And let me zoom out a little bit here and take a look at those craters right there with all that ejecta coming out of it. And at this end of the moon, we can see the crater Tycho, which is a little bit darker from this perspective. There it is. There's Tycho, that large crater right there. And if we zoom in a little bit to Tycho, we can see it's got a center mountain there. You know, craters like this are formed by large rocks, meteors, or large objects crashing into the surface, and they crash with such speed, with such energy, that the soil, or regolith as we call it, liquefies for a period of time, and then it rebounds, much like a drop of water dropping into your sink. You'll see a rebound of the water back up, and that's what happened here with the regolith, and that's what formed that mountain. It's actually quite large, that peak. I don't know exactly the size of it, but it's a big artifact there. The Tycho crater is one of the largest on the moon.
It's one that's also very visible to us from the Earth with the naked eye.
It is, yes.
Mikhail, do we have any questions from our guests?
Sorry about that. I forgot to unmute myself. Jackie would like to know, how come there are so many craters on the moon?
Thank you, Jackie, for that question. There are a lot of craters on the moon. The moon is our closest object. It's about 250,000 miles away. And during the formation, the early formation of the Earth and the moon, we went through a period called the heavy bombardment period. And the craters that you see there are mostly from that period, a period of time when a lot of debris, a lot of asteroids and rocks were floating around the solar system and crashing into the Earth and crashing into the moon. Now, we see evidence of that on the moon and not so much on the Earth, because the Earth has an atmosphere, a very thick atmosphere. So many of those rocks burnt up as they entered, but because we have a thick atmosphere, we also have a very active climate. a lot of weather. So there's been a lot of erosion of the surface of the Earth, hiding the craters that were formed. There's still a few around. There's one out in Arizona that you can go and visit. But the moon does not have an atmosphere to speak of, a very, very little bit of atmosphere. So it has no erosion occurring on the surface of the moon. So those craters are millions and billions of years old. And they've remained pretty much constant. In fact, the footprints that the Apollo astronauts left on the surface will remain there for millions of years probably, because again, there's no erosion on the surface of the moon.
So Melanie, actually, let's take Olivia's question first. Olivia would like to know, how big is the moon?
Oh boy. I'm going to have to dig back into my notes to answer that question. That's a good one.
I've got it. It's actually 22,159 miles in diameter. So it's like,
me out of that one, Ruth.
It's like driving from Los Angeles to Atlanta, Georgia, almost across country.
Yeah, that's if you go from one side of the moon to the other side. And Melanie wanted to know, how do you know that there used to be water on the moon?
That's an excellent question, Melanie. So NASA has sent many instruments, many satellites to orbit around the moon, and also some spacecraft that actually crashed into the moon. And then we have many telescopes here on Earth that have been used to study the moon as well. And there's a type of instrument that we could install on those spacecraft and those satellites, and also attach to our telescope. It's called a spectrometer. And a spectrometer can tell us the chemical composition of the surface that we're imaging, that we're looking at. So we know what the chemical composition of water is. You probably know that as well, Melanie. People say H2O, 2 hydrogens and 1 oxygen, and that's what those instruments would identify. Now, we also know the temperature of the moon. So we know that water freezes at 0 degrees centigrade or 32 degrees Fahrenheit, and the moon is much, much colder than that. So we know that the water that's there that we've found is in all likelihood frozen. So that's how scientists work. They investigate, they do experiments, they measure, and do a lot of analysis, and that's how we come up with those kind of answers.
So that we get to our images of Mars when we're scheduled, let's save the rest of those questions for the end, and let's talk about Mars.
Very good, Ruth. You know, you're the Mars expert. Why don't you start by telling us a bit about Mars?
Alrighty, I'd be happy to. The first image that Richard is going to pull up is actually an image from the Hubble telescope. So we talked about that earlier and about the differences that we will see between the Hubble telescope and the telescopes here on Earth. So when he pulls that up, let's keep that in mind so we can compare it to the image that we're going to see just a few minutes from now. So Mars is the red planet. It's called that because it's red. Actually, it's just a great big ball of rust. There's a lot of iron on the surface and it has oxidized and it's just rusty. Mars is actually about half the size of Earth. And you can see that comparison on the next slide. And it's the outermost of our rocky planets. There's Mercury, Venus, Earth, and Mars, and then we go into the gas giants, Jupiter and Saturn, that we learned about in our last star party. One Mars year is about 637 days long, so almost 2 Earth years, but not quite. But one Mars day is only 30 minutes longer than an Earth day. So when the scientists at JPL are working with the rovers on the surface of Mars, they actually live on Martian time. They set their alarm clock 30 minutes earlier every day so that they can communicate at the right time with the rovers. And one thing I particularly like, if you weighed 100 pounds on Earth, you'd only weigh 38 pounds on Mars. So you could have that extra donut with your coffee tomorrow morning.
Hey, Ruth, does Mars have any moons?
It does. Mars has 2 moons, but they're very, very different than ours. We just saw an exciting picture of our moon and learned how big it is. By comparison, the Martian moons, Phobos and Deimos, are like asteroids. And it's a picture here of what they would look like if you were actually standing on the Martian surface. And scientists do believe that they really are captured asteroids. Now we know how big our moon is. Phobos, by comparison, is only 14 miles in diameter, and Deimos is only 7 miles in diameter. So I actually walked further than that this morning.
So I told everybody about the Apollo missions and our future missions to Mars. I'm sorry, to the moon. Can you tell us about the missions to explore Mars?
Well, we actually started exploring Mars almost 60 years ago, which is hard to believe. But we started with the Mariner 4, and it started its orbit in 1964. It took 22 television pictures of the Martian surface, and it stored them on a 4-track tape recorder. Now, for the young ones in the audience, your mom and dad are going to have to explain tape recorders to you. It took 4 days to get those photos back to Earth. And these missions continued through the 70s. And much like the moon, there hasn't been much activity until we launched Odyssey. And Odyssey started transmitting data to us in 2001, and it continues to transmit data today. Its mission was to make the first global map of the Mars surface. The Mars Reconnaissance Orbiter, the MRO, was launched in 2005, and at that time it carried the most powerful camera that was ever flown on a planetary exploration mission to hone in with real clarity on details. Prior to that, the cameras could focus on something about the size of a large dining room table. But the camera on the MRO was actually able to spot something as small as a dinner plate. So this capability helped us when we launched the rovers and the future landers, so we had safety. We didn't jeopardize them on the landing. And MAVEN, the Mars Atmospheric and Volatile Evolution Orbiter, is the new kid in space. It launched in 2018, and it's obtaining critical measurements of the Martian atmosphere to really help us understand better about the dramatic climate change that Mars has experienced over its history. And we've actually had 8 successful Mars landings, starting with the Viking missions back in 1976. Now, Viking 1 and 2 are actually orbiters and landers, and that program continued through to 1980. In 1980, we launched the Phoenix, and it had a very successful but short mission of 7 months. InSight landed on Mars in 2018. And it's the first mission that's dedicated to looking deep beneath the Martian surface. And among the scientific tools on board is a seismometer that detects earthquakes. And we've discovered that Mars trembles quite a bit. So maybe the earthquake that we had 20 minutes before Perseverance launched yesterday was just Mars and the Earth chatting.
How about the rovers? We've also got rovers on the surface, don't we?
We do have rovers on the surface. In 1997, the Pathfinder mission placed the Sojourner rover. It's the little guy down at the bottom there. He's only about 2 feet long and 1.5 feet wide, and he's actually smaller than your child's radio flyer wagon. It was the first wheeled vehicle to be used on any other planet in the solar system, and it really served as the foundation for the larger Mars rovers that we have today. Sojourner was only supposed to have a 7-day mission, and it actually spent 83 days exploring the terrain and sending us photographs and taking chemical and atmospheric analysis. Now, Spirit and Opportunity launched in 2003 and landed in 2004. They were twins, and now by comparison, they're the size of about a smart car. Spirit far outlasted her planned 90-day mission, and among her discoveries, she found evidence that Mars was much wetter long ago than it is today. And her experiments also helped scientists better understand the Martian wind. In May of 2009, one of her wheels became embedded in very soft soil. And when you're on Mars, you just can't call the auto club for a tow. So NASA scientists tried all types of planned maneuvers to free her, but were unsuccessful. So that mission ended in May of 2011. Her twin sister, Opportunity, also made a lot of discoveries about the planet, including dramatic evidence that long ago there were several areas of Mars that stayed wet for an extended period of time, and led us to believe that these were conditions that maybe were suitable for sustaining microbial life. The Opportunity rover stopped communicating with us when a severe dust storm blanketed its location in 2018. So Curiosity is the newest kid on the surface. Now we're up to about the size of a Mini Cooper. It arrived on Mars in 2012 and carried the biggest and most advanced suite of scientific instruments ever sent to the Martian surface, the Mars Science Laboratory. So the rover actually analyzes the soils that the robotic arm is capturing. And if you look at the tires, the comparison there on the little blue block on the right-hand side, the large one, the silver shiny one, is the Curiosity wheel. And the zigzag pattern is actually Morse code for JPL. And the ridges of those tires, as it travels, they can measure the distance that the rover has traveled on the surface of Mars. It's still sending us a lot of information and will be joined very shortly by Perseverance.
Now, we just had an exciting launch of Perseverance. What can you tell us about that rover?
Well, it is a copycat of the Curiosity in terms of its body chassis. It does not have a scientific laboratory on board, but it will take samples, rock samples, and cache them or store them in carousels on the rover itself and also on the Martian surface for pickup by a future expedition. It'll take about 7 months to get there. It'll travel over 300 million miles, and it has 23 cameras on board. Most of them are color cameras, and it'll be the first time that we'll actually be able to witness a landing. We will see the parachutes deploy. We'll see the space crane drop it down to the surface. And another exciting thing, it has a microphone, so we'll be able to eavesdrop. Perseverance also carries a little traveler there, the Ingenuity helicopter. Now, Ingenuity only weighs 4 pounds, but it has great big ambitions. Now you say, so what's the big deal about a helicopter flying on Mars? We fly helicopters here all the time. Well, there's no atmosphere on Mars, so it's very difficult to get lift. The blades on this little guy are much bigger, and they will spin 8 times faster at 2,400 RPM than what would be required to get the same size helicopter to fly here on Earth. The helicopter will fly for a period of 30 days, maybe longer, 10 to 15 feet above the surface, and each flight will be about 90 seconds to maybe 2 minutes. But it has to do it all on its own. There is absolutely no human control or human intervention. There is a camera on board, and it will be sending pictures back to the rover, which will come back to us. So it's truly a Martian Wright brothers moment.
And where is it going to land again?
It's going to land in Jezero Crater. Now, this was chosen after a long 5-year review by scientists, And they picked this site because Jezero Crater was actually a lake about 3.5 billion years ago. On the left-hand side of your screen, you can see water coming in, the channel where water would come in. There's a river delta there that formed. The basin filled up and eventually, like a bathtub, overflowed. And on the other side, there's evidence of where this river continued. So this gives us an indication that there might be some microbial life there. The analogy with our river deltas here on Earth are very rich in bacterial and microbial life. Also, the satellites orbiting have taken pictures and using spectrophotometry have determined that there are carbonates along the lake shore, along those ridges on the left-hand side, which also lead us to believe there might be some microbial life. The last slide that I had shows the crater in relationship to the other landers and provides an idea what we're actually going to see through the telescope tonight. So do we have a picture of Mars ready?
It's we're going to have that in about 4 minutes. It may be a good time to take some questions.
To take some questions, Mikhail.
I've got some questions from our moon segment from the audience, and I also have a couple of Mars questions. Which would you like to take first?
No, why don't we take the moon?
Okay. Actually, we have a general question, which is why do we send robots to explore moons and planets? And it seems like we send robots more than people.
Well, one reason is that we want to be sure it's safe for people to go. So the robots provide us with photographs, with a lot of analysis on what the atmosphere is like, what the climate is like, what the conditions will actually be, so that we're prepared when we send astronauts into the outer space, to the moon or to Mars.
Ruth, we are getting an image now of Mars. It's I would say it's a so-so image, so I'm going to be sharing with you an image that we collected last night also.
Okay.
You can see in this live image of Mars some surface modeling, some detail on the surface. You know, we're at the mercy of the atmosphere, so probably there's a bit of dust or turbulence in the atmosphere. So let's switch over here and share with you a slightly better image. And let's zoom into that. There we go. And there we go. That is Mars. And
beautiful. You clearly see the bands.
Yeah, now what we're seeing is some of the mare on Mars there. That's the dark streak around the center. Mars, of course, rotates. So at different times of the day, it shows a different face to Earth. But what I really like about this image right here, it's actually showing us where Perseverance is going to land. Let me draw on it for you, just to give you an idea. Perseverance is going to land just to the right of an area called Syrtis Major. That's where Jezero Crater is, and if I'm accurate with my pen, it's in that area right there. That's where Perseverance is going to be landing. How long is that going to take, Ruth?
It'll be about 7 months. It will land on February 18th of 2021. So stay tuned so you can watch the landing live.
And I see something else here in this image, Ruth. I also see the southern ice cap. And that's right over here. You see that white patch there?
Yes.
that is the southern ice cap. The Mars has frozen water and frozen carbon dioxide. We know that it's in the ice caps. A lot of it is. We believe that maybe elsewhere on Mars as well. The northern ice cap is actually even larger than the southern ice cap, but the planet is tilted away from us at this time of its revolution around the Earth, so we don't see it. It's hidden back here towards the top. But we do see the southern ice cap. That's pretty exciting.
It's very exciting. It looks a little more oval than round. Why is that?
Okay, good question. I just learned about this myself. You know, we learned that like the moon, the inner planets can go through phases as seen from here on Earth. So actually, many people may not realize this, but Venus and Mercury could look a lot like they're having phases, like the moon goes through phases over the course of a month as well. We don't hear it very often, but Mars can also show a little bit of phasing like that. Now, when I took astronomy classes, we learned that only the inner planets show phases like that, the inferior planets, as they're called, and the superior planets like Jupiter and Saturn, and Mars, which are outside of Earth's orbit, you know, don't show that kind of phasing because they're much further away. But it turns out that Mars, because of its proximity to Earth, it's much closer than Jupiter is, and because it can get in certain angles between the Sun, the Earth, and Mars, it can actually form or appear to form what we would call a gibbous phase, like the current phase of our moon. So it doesn't look completely round, does it? Does it?
No, it doesn't.
It looks like only about 90% of it is illuminated by the sun, and that's because of the angle between the sun, Mars, and the moon. That's what we're seeing right now.
Do we have any questions, Mikkel?
Yes. Yes, indeed. The Quack family would like to know. Okay, I'm going to read questions from the chat box. So if you have questions to ask, go ahead and type them into the chat box, please. So back to our questions. The Quack family would like to know, how come the Earth's moon is bigger and round and Mars's moons are smaller and odd-shaped?
We're getting a lot of good questions tonight, aren't we?
We are.
Well, that's a really good question, too. So we believe that the moon formed after a minor planet collided with the Earth. And that collision threw a lot of debris, pretty much a large portion of the Earth's interior out into its orbit. And over millions and millions and billions of years, it coalesced and formed this round body that we call the moon. Now, the moons of Mars look quite different, as you saw in that slide that Ruth shared earlier. We don't think those moons formed like that. In fact, we believe that possibly they were captured asteroids that were floating through our solar system and got maybe a little too close to the planet Mars, and the gravity of Mars held onto them, and essentially they became satellites or moons of Mars. And that's one theory about the moons of Mars. They're also very small, and it takes a lot of mass or a lot of material and the gravity that creates to actually cause a body like our moon to form into a sphere, to form that round shape. Something that doesn't have enough mass or dirt, if you would, may stay very rough and odd shaped, and that's why a lot of asteroids aren't round as well. They just aren't big enough to have gravity formed them into a spherical shape.
All right. Janine asked, what are the dark and light colored bands on Mars, and what makes the dark areas darker?
Ruth, would you like to tackle that one?
I thought maybe you'd tackle that one.
I'll take a stab at it if you guys want.
Okay.
So there's different kinds of dust on Mars, and some of the areas are like some of the lighter, well, first of all, the very bottom, that where we see the lighter part, can you point to where that ice cap is in our picture, Richard?
Sure. Let me draw.
Yeah, let's go back
that.
to our picture.
Mm-hmm.
Okay, so we have, do we have the, yeah, there it is. So if you can point to the ice cap, please, Richard, down there at the bottom, that's an ice cap made of water and dry ice. And so that's white because it reflects more light. Then we have some medium colored areas in the middle. And then across, right now it looks like it's across the middle. In that center area, we have a darker area, and that's an area where there was a lot of volcanic activity. So there's darker colored rocks from lava flows. And there's also in those latitudes, there's dark dust from when the atmosphere of Mars has eroded the dark rocks and made dark colored dust that it's blowing around. And unlike the moon, which has no atmosphere, so you really can't get dust blowing around on the moon because there's no air on the moon for the dust to blow around in. But on Mars, you do have an atmosphere and you have wind. And like the winds on Earth, the major air flows in the atmosphere are in latitudinal bands. So they kind of, in that area where the equator is, you get a lot of wind, and that's why it's blowing a lot of that dark dust around. So that's how come we have kind of that darker area in the center. All right, we have some more questions about Mars. Let's see, Caitlin is asking, how come Mars is not showing up red in the picture that we're looking at?
Well, this is a black and white picture like Richard was talking about earlier with the telescope. They see them in black and white, and then they use filters to colorize them after the fact.
Mm-hmm. So you might remember that Richard showed us the picture of the filters on the camera, and there was like a red, green, a blue, and a kind of purplish one. Well, they take the red and the green and the blue, and they kind of pile 3 pictures on top of each other, one taken with the red filter, one taken with the green filter, and the third one taken with the blue filter, and they pile them up on top of each other, and they make what's called a false color image. And it actually works the same way as your color TV works to make color images. All right, we've got another really good question from Samantha. Is there water still on Mars?
Well, there is no water on the surface of Mars any longer because the atmosphere doesn't support that. But we believe that there might be water trapped underneath the surface in the rock formations.
Now, when you're talking about water there, Ruth, you're talking about liquid water.
Liquid water, right. Obviously, there is frozen water in the caps, which is also part carbon dioxide as well, but there is no liquid water on the surface.
And why is liquid water so important, Ruth?
Well, that's what supports life. So we have to have oxygen and we have to have liquid water to be able to support life. And that's why we're looking for the ancient life, thinking long ago there was liquid water on the surface of Mars, which could have supported very small microbial life. We're not looking for dinosaur bones. We're looking for little tiny single cell life, algae, bacteria that would still be within the rock layers.
Very cool. So we don't know if there's life on Mars now, or maybe in the past when Mars had a thicker atmosphere and it had more liquid water on it. And part of the reason that we're landing where we're landing is because we think it might have been an ancient lake bed. This is the Perseverance mission that just launched to Mars. And the area where it's landing, they think it might have been an ancient lake bed. And so in lakes, that's where you get a lot of algae and stuff. So we're going to go look for signs of that.
There's actually, in Australia, there's a desert now that's about 3.5 billion years old, the same age as Mars, where they have found stromatolites. So it's like a mat of algae fossil. And that's what we're hoping we can find things like that in the Jezero crater.
And then Samantha is asking, oh, we already talked about, is there still water on Mars? Kenzie is asking, what is the temperature on Mars?
Ooh, I'd have to look that one up. I know it's well below zero because they've included a little heater actually in the Ingenuity helicopter to keep it from freezing overnight. Richard, do you have any idea?
Yes, I do. It frequently gets below 100 degrees Fahrenheit, below zero, below 100 degrees Fahrenheit. And in the sun, it can get quite warm, 80, 90 degrees Fahrenheit in the sun. So the variation of temperature is quite broad on the surface of Mars.
Very nice. So, Ruth, what are we going to learn from NASA's current mission to Mars? We talked a little bit about maybe looking for signs of life on this old ancient lake bed, but what other sorts of things can we learn from the NASA mission that just launched, Perseverance?
Well, we're looking to characterize the climate of Mars. Mars has gone through very dramatic climate change. If it had water at one point in time, like the ancient lake bed, and now has none. So we are looking for evidence of microbial life that could have existed, and we're also looking to find answers about the climate change, which could help us then understand the climate change that the Earth is experiencing at this time. We're looking at the geology of Mars. When you think about the Grand Canyon, if you've seen pictures or you've been there, you see many, many, many strata of rock. And these were all formed at different periods of time, some formed underwater, some not. So by studying the rock layers, we'll have an idea of the actual formation of Mars. And then, of course, to prepare for the Artemis launch, to prepare for human exploration. So using the technologies that we have on board and using the natural resources in the Martian environment to support life and fuel. One of the fascinating technologies that will be tested is called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment, which is a mouthful. That's why we're calling it MOXIE. The atmosphere of Mars is 95% carbon dioxide. And so just like a tree, MOXIE will breathe in the carbon dioxide and split apart the carbon and the oxygen atoms and make oxygen, which we need to support life for our future astronauts and also to use for rocket fuel to return them back to Earth.
Very nice. So Charu was asking, what plans do we have to send people to Mars?
Well, that's part of the Artemis mission. There's not a date yet to do that, but they will be returning to Mars. They're thinking sometime in the 2030s is kind of the optimistic date. The next mission may be 2031 to bring back the rock samples that we're collecting and soil samples and we have a lot more research to do before we can send people that far away. It's a 7-month trip and 300,000 miles, so we have to be very cautious and very careful when we send our astronauts there.
Mm-hmm. So Kathy and Annie and Kelly asked, if Mars is below 100 degrees, how does that compare to the coldest places on Earth and to other planets?
Ooh, well, the other planets that are further out would be colder, although they are gaseous in nature. Antarctica, the Arctic, our ice caps are very cold. I don't know what the temperature is. I only remember living in upstate New York and having minus 54, which was cold enough.
Yeah, I think that Mars is colder than even Antarctica gets in the middle of winter. It's
Yes.
pretty cold for people there. And when we send people there, one of the things that we'll have to prepare is we'll have to make sure that we have ways of keeping them warm enough and having enough water for them and collecting enough solar energy probably to to provide them with electricity to run the equipment that they need to stay safe.
And one of the parts of the technology on this time, they've taken fabric for spacesuits to test it and see how it survives in the Martian environment.
So
I've got to speak up for Pluto. Everybody forgets about poor Pluto, the newest dwarf planet. It gets below minus 200 degrees Fahrenheit there, cold enough actually to freeze nitrogen, which, believe it or not, is gaseous here on Earth. That's most of the air, what makes up most of the air that we breathe. So on Pluto, it actually gets cold enough to turn that into snow.
Ooh, that's too cold for me.
Me too. Well, we're pretty close to wrapping up. Maybe if we take one more question.
Okay. Bindu would like to know, what is the farthest thing out in space that people have ever explored?
Well, people have only been as far as the moon. We have satellites that have gone well beyond our solar system now, but we have not had people or astronauts any further than the moon.
Yeah, and in fact, the International Space Station, where we have people right now, is only about 250 miles up. So that's not very far. How far did you say the moon is?
Quarter of a million miles?
Quarter of a million miles from us? Yeah.
Yeah, so that's a whole lot farther than the International Space Station. And it takes a few days if we send astronauts up to the moon. But right now, these like Perseverance and the other moon missions that have launched this summer are going to take, the other Mars missions that have launched this summer, it's going to take them 8 months to get to Mars.
They're traveling over 300 million miles.
Yeah, Mars is really far away. The very farthest thing that we've ever sent out away from the Earth are the Viking 1 and Viking 2 probes, and they've actually reached the edge of the sun's influence. So they're actually out in interstellar space now, which I think is beyond cool.
Yes, considering how old they are too. Well, for everyone, I'd like to share some resources with you. You don't have to rush and write all of this down because we will be putting this up on our website at scienceheads.org. There's that information. There's information about the telescopes, and NASA has just a wealth of information on all of the missions, on all of the satellites, on all the planets and the moons. There's a fascinating program called Eyes on the Solar System that you can download for free. And you can travel throughout the solar system, and I personally can get lost there for hours. So we appreciate all of you being here tonight. We ask, if you're interested, to check us out on Science Heads. We have 2 upcoming star parties, August 14th at 5 p.m., and it's actually going to be on the secret life of stars. So it's going to be much more interesting than a Hollywood soap opera. And on the 29th of August, we'll be looking at our sun. So we'll be using our own mobile observatory with our solar scope to look at our dynamic universe. You also can chat with the Solar System Ambassador. You can schedule that on our website. Again, that's scienceheads.org. So on behalf of Richard and Mikkel and myself, thank you very much for joining us tonight. Stay well and be safe.
Bye.
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 Bye, everyone.
Bye. 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 Thank you. Bye. 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 Okay. Bye. Can you hear you?